Welcome everyone. Today we'll deal with your most eternal curse, fractions. Welcome to another episode of Math and Silly Hats. Today we're going to be writing unit fractions with a common denominator. We're given problems where we have two different fractions, each containing an unlike denominator. We'll have to add or subtract those. So there's a couple of steps we'll need to do to get the same denominator before we can add or subtract. First, we're going to write each fraction with the same denominator. We may need to factor each fraction to understand what special form of 1 we will be multiplying one or more of those fractions by to get to, again, the same denominator. Once we have the same denominator, we're going to add or subtract across the numerators. So just the tops of the fractions, and keep the original denominator to find our solution. Let's look at a problem now. So here we're asked to subtract these two fractions, and they obviously have different denominators. Let's write this on the board before we solve it. Now we're given some clues in this problem. You'll notice here they show us that this first fraction, 1/3, will change to some number of sixths before we subtract. Now they don't give us the final denominator of our solution, but if we look at our steps, we'll note that after we add or subtract across the numerators, we're going to keep the original denominator. So before we do anything else, we know that our answer is going to be in terms of sixths. Now, let's write out how we can figure out how 1/3 will change to some number of sixths. Now, for some of you, it may seem obvious what number we're going to multiply 1/3 by in order to get to sixths. But for the rest of you, let's factor sixths. So sixths can be written as 3 times 2, which is notable because we need to figure out how we can multiply 3 by something to get to 6. Let's go back to what we started with. 1/3. We have to multiply it by a special form of 1, some number over itself, in order to get to sixths. Well, 3 times something is going to be 6. When we factored 6, we noted that 6 was equal to 3 times 2. So in order to get 2 sixths, we can multiply 1/3 by 2 halves. And we're allowed to do this because 2 halves is a special form of 1, and the multiplicative identity says we can multiply anything by 1 and it will keep the same value. So when we multiply 1/3 by 2 halves, we're going to end up with 2 sixths. So we have our first blank. 1/3 is equal to 2 sixths. Now to solve this, we're going to add or subtract across the numerators and keep the original denominator. So 2 sixths minus 1 sixths, well, 2 minus 1 is going to be 1, and we keep the original denominator of 6. Let's put that into ALEKS. Alright, so over in here in ALEKS, we know that our denominator is going to be sixths because we keep the denominators when we subtract fractions. From the first step we did, we multiplied 1/3 by 2 halves to get to 2 sixths. Once we had fractions with the same denominator, we could subtract across their numerators. So 2 minus 1 is 1, and we keep the same denominator, sixths. Let's do one more problem. Here we're adding two fractions. Again, we'll have to find a common denominator before we can add them. Let's go back over to the board. Okay, so our setup is similar, except for we're adding here. Again, we're given 1/8 is still going to remain 1/8, but our 1/2 will turn into some number of eighths. Again, because we're going to be adding eighths and eighths, we know from our second rule that our ending denominator will be the same as the original denominator, eighths. So we can go ahead and fill that in. Now, let's convert 1/2 to some number of eighths. So we're going to need to multiply 1/2 by something to get to some number of eighths. And again, if we need to, we can factor 8 to see that 8 is 2 times 4. So, to get from 1/2 to some number of eighths, we have to multiply by some number over itself, and 2 times 4 will be 8, because we know 8 is the same as 2 times 4. So we need to multiply that by that special form of 1, 4/4. When we do that, we'll notice that 1 times 4 is 4, 2 times 4 is 8, and we did get to eighths. So let's go ahead and rewrite 1/2 as 4/8 in our equation. Given 1/8 plus 1/2 is 1/8 plus, we know 1/2 is now 4/8. And then finally, we're going to add or subtract across the numerators and keep the original denominator. So we've got the same denominator. We can now add across the numerators. 1 plus 4 is 5. And because we're working in eighths, we're going to keep our original denominator of 8. Putting that into ALEKS, again, we had to change 1/2 to some number of eighths. We know that 1/2 times 4/4 is 4/8. Because we're working in eighths, our answer is going to remain in eighths. And once we have the same denominators here, we can add across the numerators. 1/8 plus 4/8 is 5/8. I hope that you found this helpful and that now you can answer these questions on your own in ALEKS. Have a great day, everybody. Bye-bye!